Thank you for joining me today, everyone. I hope everyone's having a nice day. Mr. Ish here. We will be doing a video part 2 on binomial theorem. And if you've seen my video part 1 on the same subject, then we should continue from where we left off. Before I do, I just want to very quickly review this concept because this is the crux of the binomial theorem. These combinatorial coefficients that you will determine using the formula NR, right, which we know to be n factorial over r factorial and the difference of n and r whole factorial. Very quickly, if you have a question which states 8c3, what does it mean? Well, here's my n, here's my r, 8, 3 in this format. Then we do 8 factorial over 3 factorial because this is my r, and then 5 factorial because 8 minus 3 is 5 factorial, and then you can calculate this. And remember, this symbol is a factorial. Products of all the numbers shown here all the way down sequentially till 1, not 0. And remember, at any time you see anything which looks like this, 0 factorial, you can either eliminate that from your equation or you know 0 factorial equals 1. So remember that 0 factorial is always equal to 1. Remember, this right here is a symmetrical binomial, a plus b to the power of n, where the coefficients of a and b are both 1. So you'll have a symmetrical binomial. Let's look at this example over here. 3a minus 2b to the power of 5. The first thing we need to pay attention to the fact is this is my exponent n, 5. So we know we will have 6 terms. It's always n plus 1, right? N plus 1 gives you your 6 terms in total. So let's show you this in terms of the expansion. The first thing we're going to do is write it in the NR form. We're going to write 5 in this form. Remember our NR? The first number you're going to put down here in place of R will be a 0 because you're going to sequentially work 0 up to 5. And then you know your binomial expansion is completed. And then we'll put 3a over here because this is my a. The a is entirely the 3a, not just a, but the full 3a is your representative of your a over here. And it's always n minus r, n minus r. So 5 minus 0 will be a 5. Here's my b value, 2b. And here the exponent is always r, which happens to be a 0. I'm not putting a plus or minus over here yet. Let's go to the next number right here, 5, 1. Because we're going to work this 0, this 0, which represents the r, all the way up to 5, then we'll be done. 3a to the power of, it's always n minus r. This exponent here is n minus r. 5 minus 1, 4. And my b value, which will be 2b, and it's always exponent r, which happens to be a 1. Let's put the next round right here. 5, 2. And then we will put here a 3a to the exponent of n minus r, which is a 3. Finally, the 2b value to the exponent of r, which is a 2. Let's go to the next expansion. We have 3 terms here. We need to end up with 6 terms and we'll be done. We'll come over here. 5, 3. And let's keep this expansion going. 3a to the power of n minus r. 5 minus 3 is a 2. And then b, which happens to be a 2b over here, to the power of r, which is a 3. You can see this exponent on b is sequentially working its way up. The next expansion item will be 5 and a 4. When it's a 5 and a 5, we're done. 3a to the power of n minus r. 5 minus 4 is a 1. B term. 2b to the power of r, which is a 4. And lastly, 5 and a 5. Now we know we're done because we have n and r are equal to each other. 3a to the power of n minus r. 5 minus 5 is a 0. And finally, 2b to the power of r, which is 5. We don't have to expand, we don't have to open all of this out because we can calculate that using a calculator. But let's look at what happens with the signs. If you have a minus sign here, the first term is always a plus. Then you'll do alternate plus, minus, plus, minus, plus, minus. That's how the signs are going to work out. You'll always start with the plus, then you'll alternate the signs as you go across. If you look at just these NR coefficients, NR 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. If you were to calculate them out, you'll have symmetrical coefficients in terms of the Pascal's triangle. What spoils the symmetry over here are the coefficients 3 and 2, because now 3 and 2 are going to impact with this combinatorial coefficient and it will spoil the symmetry across, but that's fine. You'll always still have the symmetry with the exponents. look at the symmetrical exponents. You start with a to the 5, then 4, then 3, then 2, then 1, and 0. But likewise, b exponent will be 0, 1, 2, 3, 4, 5. So you'll have that reverse symmetry going on. And this can be expanded. Let's look at another example, but without numbers. Just the general theory behind how this works. Very generally, the binomial theorem, using a symmetrical binomial coefficients over here. The expansion rule is this, and I'm going to just lay it out for you. You always start with the n and the r. The n represents your maximum exponent. The exponent you start with. The a term will always be n minus r. You see, it's n minus r. And then the b term will always be this r value here. But what happens when we do the next term? We have to bring a minus over here because it's going to be a plus minus till however many terms we have. Now look what happens over here. Here we have n, but here we'll get r plus 1. I haven't showed you in this form, but this is exactly what I've been doing. Remember, I was sequentially working the r all the way up till it hit the n. And then what happened over here to the coefficient of a? It became really n minus, but whatever this term was, r plus 1. See? I'm showing it to you in terms of the algebra over here, but the concept is exactly the same. It was always n minus r, but here r was r plus 1, so it became n minus r plus 1. And what was the exponent of b over here? The exponent of b over here was r plus 1, because remember the exponent of b was gradually increasing from 0 till whenever. So you're going to follow all of this procedure where this exponent right here gradually increased by 1, and the exponent of a gradually decreased by 1, and the exponent of b gradually increased by 1 until the very last term. It could have been a plus and minus over here, but then in the last term, here it was n, and here it became r was equal to n, because here the value of r worked its way up to n. What happened to the exponent of a? It basically became n minus n. Remember, that's why it zeroed out. It became n minus n. Anything minus the same thing became a 0. So this worked out its way to 0. And then b became to the power of r, which was also b to the power of n, because here r was equal to n. So this is basically the gradual way you work your way when expanding it. Remember, when you have a plus sign over here, everything will be a positive. But when you bring a minus, you're going to alternate the plus minus till you're completed. And you have to remember how the exponents change and how these r values change across. The exponent of b is always what the r value is, and the exponent of a is always what the n value is initially, but always decreased by 1 as you go across. I want to show you a different type of binomial theorem question where you are given a question and you have to find a specific element of that expansion without fully expanding it. I want to show you this question here, and I'm going to be using a calculator for it because I'm going to give you the direct exact answer. 4a minus 2b to the power of 7, and I want to find the fifth term. We know just by looking at the 7 we'll have 8 terms, right? 7 here implies n plus 1, which means 8 terms, but we want to find specifically the fifth term. So what's the procedure for doing that? And we know we have the coefficients here which are non-symmetrical, so we'll have asymmetrical expansion, but that's fine. The process for finding the fifth term is you have to find the r value. Remember over here, here's my n and r. We have to find the r value. What's the r value? The r value is always equal to, instead of putting the equal, let me put a colon because I'll be putting an equal very shortly. The r value is always n minus 1. What's your n? The term you're finding. The term. Here is my n right here. So that makes it what? 5 minus 1, which makes it 4. So here r is equal to 4. Okay? And we always know the n value. The n value is always the initial exponent. You see this initial exponent right here? That feeds into this n right here. And this r value just feeds in right over here. And you have everything you need now to expand this out. And you're going to write it as this 7, 4. And you know what you're going to do over here. It's basically the combinatorial coefficient, but we will work all of that out. You will put your exponent term, the first base for the first exponent, 4a. But remember, the exponent here is always what? It's always n minus r. 7 minus 4, n minus r. And the next term here is a 2b. And the exponent of this second term is always r. You just take that number and you put r over here. We need to find three things. We need to find the term over here, Actually, four things. We need to calculate this, we need to calculate this, multiply them all together, and lastly we need to determine, are we going to have a plus or a minus? That sign determining will be occurring at the very end. Let's solve this part out. Remember, NR is 7 factorial over 4 factorial and 3 factorial. 3 factorial is from 7 minus 4 factorial. This is multiplying with 4a cubed, which is multiplying with 2b to the power of 4. And if you do this entire computation, I'm doing it here on my calculator, I'm going to get 35. This part right here, the combinatorial coefficient is 35. But 35 is going to multiply with 4 cubed, which is a 64. And that is going to multiply with 2 to the power of 4, which is a 16. I will get a 35,840. That's my coefficient. Let's bring in the letters a to the cube, b to the 4. But I want to make sure before I present this that I'm right. So I'm going to recalculate this. And I do indeed get 35,840 a cubed b to the 4. And as I said before, the last thing we need to determine is the sign, because this minus here complicates it. The procedure for determining the sign is you can do some finger counting. But since I'm making a video over here, I'm going to do some counting right here on the board. I know I have 7 numbers, a 7 exponent which has 8 terms. So let's just write it out. 1, 2, 3, 4, 5, 6, 7, 8. The exponent 7 upon expansion gives me 8 terms. So just 8 terms. So just start labeling them as plus minus in an alternating manner. Plus minus, plus minus, plus minus, plus minus. But I said let's find the 5th term. Remember our question was the 5th term. You look here at the 5th term, right? It happened to be a plus, so we're good. So it's 35,840 a cubed b to the 4th. Not actually calculating all of this out, but if the question had stated what's the 2nd term, you would look over here and you know your 2nd term would have to be a minus. If the question stated what was the 8th term, you could calculate all of this part out, but you know the 8th term has to be a minus. Let's look at one more question before we wrap this up. Let's look at this question, an asymmetrical binomial, a minus 3b all to the power of 11th, and we have to find the 9th term. It's not symmetrical by any means, asymmetrical, and there's a minus sign which compounds it a little bit. The first thing we should do when you're tackling these type of questions is start with this format right here. We're going to start quickly plugging in what we see. N value is always what you are given in terms of the maximum exponent, that's my 11. Our goal here is to find R. R is always equal to whatever term you're given in terms of finding, you do n minus 1. Because remember, 11 here means 12 terms. If I have to find the 9th term, I do 9 minus 1, and I'm actually focusing on the 8th item of the array. Remember, array is a list of items, so I'm actually focusing on R equals 8. I'll put 8 over here. Then let's put the a and b components. A here is just a. There's no coefficient other than a 1. The exponent of a is always n minus r. I'll put it here, n minus r. But n minus r is 11 minus 8, which happens to be a 3. The exponent of b term, remember b term here is not a minus 3b. You do not marry the minus sign here with the thing, because minus stands on its own as a format of the question you're given. It's 3b, and the exponent here is always r, which happened to be 8. You know how to solve the combinatorial coefficient over here, 11 factorial over 8 factorial and 3 factorial, because it's n minus r aspect in the denominator. Sometimes if you have very large numbers here, sometimes your calculator may have an issue with solving it, but we're not going into those high numbers. So we'll just do 11 factorial, and we will divide that by 3 factorial, and then we will divide that by 8 factorial. And I end up getting 165. This right here equals 165. So I basically get 165 multiplied by a cube multiplied by 3 to the power of 8. You know 3 to the power of 8 is going to be a large number. So again I have my calculator here, and I have 6,561 b to the power of 8. I have to combine these coefficients to generate a final answer. Before I do that, I want to make sure this 165 term is right, because if your combinatorial coefficient is wrong, your entire question will turn out to be wrong. And I'm doing that just right now, and it turns out to be right. So 165 times 6561 gives me a 108. See, the number is going to be pretty large. 2565. So it's going to be 1,082,565 a cube b to the 8. This right here is a 3 over here. Our goal here is now just to determine the sign of this. You can do this on your fingers. I'll actually do it here on my fingers, or you could have written out all the terms. I'm going to count up to the 9th term. Never count up to the 8th term, because you're going up to the question, the item which is asked in the question. So let's start with 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm going to do plus, minus, plus, minus, plus, minus, plus, minus, plus, and I did that all off screen, but I was using my fingers, and I got a plus over here. Essentially what I was doing over here, I had my fingers over here, and I counted all the way up to 9 as a plus, minus, plus, minus, plus, minus, plus, minus, and plus was my 9th term, and it happened to be the 9th term that I'm looking for. So this is actually my final answer. And again, if someone had asked like for a different term, you would have to run down that same scenario by calculating a new n and r value, and you'd actually solve your final answer, and you'll determine to see if it's a plus or minus. Again, you can use the fingers, or you can write them all out. The foolproof method is always write them all out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm stopping at 9, and this was a plus, minus, plus, minus, plus, minus, plus, minus, and plus. So I knew I had a positive answer. These questions can always be worded in a different manner. You could have had, I'm not going to solve it out, but I'm just showing you a different way. This exact same type of question can be worded out. You could have a situation, let me just erase this part over here, and I can just show you very quickly how a different type of the same question may appear. You could have a scenario where you have 2x minus 2y, could have been a plus and minus to the power of 10, and the question says find the middle term. See, the middle term. Now we're not even being given a number. You see here, find the 9th term. Here the question is find the middle term. Now what do we actually do? It's slightly different. In this case, all you have to do is see what middle represents in terms of math. Middle means half. You do 10 divided by 2, and you do 5. Here automatically r is equal to my 5. You're not going to start doing n minus 1. You're not going to do like middle term happened to be 10 divided by 2 is 5. Now I'm doing a 5 minus 1 like over here. You're not going to do that 5 minus 1 anymore, because then you're going to reduce your final answer by another item beforehand, alright? When you're given a qualitative description of your question, you're going to determine exactly what it represents in terms of number, and that will be your r value. Do not make the mistake of projecting that further in an n minus 1 and determining a new r value. So that should wrap up this video. Be aware of the processes and procedures presented in both videos, part 1 and part 2, and the various trends you need to be aware of, and how the expansion occurs, and especially how the plus and minus technique is. Lastly, be aware of how to find a specific term. You can be asked to find multiple terms within a very large expansion. This question could have been find the 1st, 4th, 7th, and the 10th term, and you would carry it on through the same procedure. And also be aware of how this type of question can be modified to represent a more qualitative description versus a quantitative description. Well, thank you for enjoying this video and liking and subscribing. Please share it with your friends. Have a great day, and thank you again. Bye.